All right, in this segment, we are going to look at percentages and the word problems that encompass them. There's a ton of percentage word problems out there. I mean, realistically, this is probably one of the most real life applications of math that you can have. However, we're just going to look at a few, and we will start now. All right, so I don't know what state this is in or how old this is, but it says a teacher earns $18,500 per year. If 18% of her income is withheld for taxes, how much money is withheld for taxes and how much of her income is left after taxes? So we always have to be careful what we're looking for, what questions they're asking us for. But ultimately, these all fall into one category. And if we kind of go off of that equation that we were working with in our previous segment, it is this. The part will equal a percentage of, which is multiplication, the whole. W-H-O-L-E, whole. Okay, so the part will equal a percentage of the whole. Now, again, sometimes I like to think of things as part and whole. Part and whole is better than is over of, if you remember that mnemonic device. If you don't, just forget I even mentioned it. Part and whole isn't bad because if you want to think of it like, the whole, another word for that is the total, whereas the part is the piece, because basically that's what percentages is really talking about. You're finding parts of wholes or pieces of the total. So if we look at this one, the teacher earns $18,000 per year. That number is your whole, right? That's the whole amount that she earns. Now, the percentage is somewhat easy to find in this one. It tells us 18%. And they want to know how much money is withheld for the taxes. So this is our X. I mean, we don't know this. Remember, we need to have an X for these. But it also represents our part or our piece, because while taxes may take a lot from your paycheck, they don't take the whole thing. So if I am plugging in, part equals percent of whole, okay, I pretty much have it mapped out. The 18,500 goes here. Now, remember that if we're dealing with a percent, we cannot plug it in as a percent. You must change it to a decimal. And if we're changing it to a decimal, that means we're really moving the decimal to the left. And this is where you have to pull all that stuff from that first segment. So 18%, if I have my decimal there, I need to move it 1, 2. So this is really 0.18. Okay. And then the part is this tax amount, and that's what I don't know. So essentially I have X equals 0.18 times 18,500. Now, we split that equal sign. If our X is attached to something, we need to undo it, as we learned with the proportions. But if we just have these two numbers, X equals 0.18 times 18,500, we can do that. So we're going to plug that in, 0.18 times 18,500, and we get 3,330. So that represents our taxes. So our taxes will be $3,330. Okay, and if we want to know how much of her income is left, Then we're going to take her full amount, 18,500. We're going to subtract the 3,330. And we can do this by hand or with our calculator. We might want to check with our calculator for accuracy. And we get 15,170. So income after is $15,170. So our two answers are that her taxes cost her $3,330 and her income after taxes is $15,170. All right, so let's try this one. A carpet salesman claims that a carpet is on sale for $12.95, is 30% off its original price. What is the original price? So again, if we're looking at this, part equals percentage of the whole, okay? The on sale price is not the whole amount because we had a price, we took some off of it and we got the $12.95. So now we look at this and here's the little bit of the tricky part to this one. You have to make sure the percent and the price, anytime you're doing this, match. So 30% is not representing the sale price. 30% is representing the amount off, okay? If we're looking at this $12.95, which is our part, by the way, we said we knew that, it's not our whole amount. $12.95 does not represent the 30% off. It represents the 70% that we're paying for. So because it represents the 30% that we're paying for, the 70%, did I say that? The 70% that we're paying for, in our percentage spot here, we need to have that match. So here we're not going to put 0.30, we're going to put 0.70. Because again, these two pieces need to match. If they were saying that our discount was $3, then we would use the 30% off because our $3 is what we're getting off. But because they gave us the $12.95, the piece that we're paying for, that's what we go up to the salesperson and pay, we need to use the percentage that we're paying for, which is 70%. Now, if you're asking how I got that, well, total, it's 100%. So if we are getting 30% off, that means we're paying for 70%. And then our whole amount, which we don't know, because that's what we're looking for. We want the original price. So now we set up our, I'm just going to rewrite this without all the words. And I get this, $12.95 equals 0.70 times X. Now what we talked about in our proportion section is that when you have something attached to X, you undo it by doing the opposite. So 0.70 times X, so we are going to divide both sides by 0.70. We're going to cross them out on the right and it leaves us with X. And when I do the $12.95 divided by 0.70 on the left, I get 18.5. Now, because we're talking about dollars, okay, the original price is $18.50 or $18.50. All right, number 3, to keep pace with a 4% inflation rate or rate of inflation, how much should last year's 0.37 or 37 cent stamp cost this year? So one thing to note, especially since we're inflating something, if we look at this, this can also be written this year equals the percent of last year. Okay, so this year equals the percent of last year. This year is going to be some part of last year's. So again, if we look down here, the trick with this one, and I tried to pick these that had a trick to them. If we think about this, part and percent and whole, with what I just said, this year is going to be some percent of last year. So we don't know the part because we don't know the this year, but we do know last year's, which is 0.37. Now, we do know the rate of inflation, but here's the thing. It's inflating by 4%. You're still paying for all of what it cost last year. So you're paying the whole 37 cents, but then you're paying more on top of that. So again, remembering what I said about these two things needing to match, that X is not going to be 4%. What it is, it's going to be 104% because you are paying for 100% of last year's cost. If you think just purely from a percentage standpoint, you're paying 100% of last year's cost plus the 4% inflation for this year, which gives you a total of 104%. Now, when I plop my decimal in and then move it over 2, that means in this spot I really get 1.04. Solving this, I get x equals 1.04 times 37. Again, since my x is all alone, I'm good. Then I want to do 1.04 times 0.37, and I get 0.3848. Now, because I am in cents already, and this is talking money, I went from 37 cents. I only want to keep the 2 decimal places, but I need to look at the third one to say if I'm rounding, which I'm not. So the stamp costs 38 cents because it does not round up. So again, you have to remember what, you have to keep in mind, like, are you ending with a percent? Because if so, you need to move the decimal. If you're not and you're working with money, you need 2 decimals. You kind of just have to play it by ear. Because even though this said round to the nearest tenth, okay, that's for most of them, but we've been talking about money so far. So money, you don't want to round to the nearest tenth, okay? All right, in an election, one candidate claimed 52% of the votes, while the other candidate claimed 2,681 votes. If 5,000 people voted, how do you know that the election results are invalid? Full disclosure here, I used this question last year and it was not election year, so this is no attempt to be political at all. So we have essentially, you're saying that there was an election and there was a total of 5,000 votes. Now, if it went 50-50, in terms of numbers, it should have been 2,500 and 2,500. If it went split right down the middle. If it went in percentage-wise, it would be 50% and 50%. Now, basically, if this is candidate 1 with 52%, that's saying that they won. Okay, but then on the other hand, you are saying that candidate 2 got 2,681 votes. This is above 50%. or above, let me write it differently, above half, if you will, and this is above half. You can't have two candidates having above half if the results are going to be valid. If one is above 50%, the other would have to be below 50%. So that's how you know. Both candidates cannot have greater than half the votes, because the whole thing is you're adding up to a whole. You're adding up to 1, you're adding up to 100, you're adding up to 5,000 in this case. So you can't have it be more than half for each of them. All right, so try some of the percentage word problems. They're all a little bit different, but again, you're always trying to put that part equals percent times whole, and you want to make sure that the part number is matching the percentage.